Hello. What I'd like to show you today is my MAP/MAF sensor. I sell several models of these on eBay. This is the simplest one with just the one knob. What I've have this installed on is my 1999 Toyota Sienna. It has a MAF sensor, MAF, that stands for mass airflow sensor, and what that does basically is measures how much air is coming in the intake of the vehicle and sends that information to the computer. This helps the computer to know how much fuel to mix with the amount of air that is currently coming in. So what this device does is it throws some resistance into that circuit. Basically, the more that you turn the knob toward the lean position, the more resistance is put into the circuit, and this causes the computer to think that there is less airflow coming into the intake than there really is. The net effect of that is that the computer puts less gasoline into the mixture than it would normally. Therefore, we're leaning the mixture. Some vehicles have a MAP sensor, MAP, that stands for manifold absolute pressure. Basically what it does is measure the vacuum in your manifold, and it sends a reading to the computer for the same kind of purpose of deciding how rich or how lean to make the fuel air mixture. This device works with both. However, I will say that there are some sensors that, rather than varying the voltage, vary the frequency instead. This device will not work with those. There's also a possibility that on some vehicles the computer will see a reading coming from the sensor that seems incompatible with readings it's getting from other sensors, particularly the oxygen sensors. In that case, this device may not work alone. You may also need to put oxygen sensor extensions on those, or a FE, an oxygen sensor adapter that or enhancer that will change the voltage sent to the computer from those. That takes a different type of device, a little more expensive device, because voltage actually needs to be added to the voltage sent by the sensor in that case, and it's a more complicated circuit. Well, anyway, on my 1999 Toyota Sienna, I'm running with just this simple device here. And the way that I've set this, you've noticed that there's a couple of pencil marks here. What I did is, while I'm sitting and idling, as I am right now, I turned the knob from the off position, slowly leaning it out further and further until the engine started to run rough. And then I backed it off a little bit to a point where the engine runs very smoothly, as it should, and put a pencil mark there. So that's what it's set on right now. And then what I did is I took it out on the highway and accelerated heavily and gradually turned this toward the rich side in order to eliminate any ping that might happen when I'm accelerating heavily. And I discovered that setting it right there, it did not ping, and gave me good performance, good power. Not full power, but for most situations, plenty of power for my driving habits. So what I ended up with is this range from this mark to this mark that I felt was a safe range to be adjusting in. I've purchased this Scan Gauge 2. You may have heard of those. I understand the orders for those have quadrupled. I had to wait 2 weeks for it to be shipped, but it was well worth the wait because it really helped me to determine if I'm doing any good here or not. So what I'd like to do, well, before we go there, there's something, if you have one of these scan gauge 2, one of the gauges is this, what this stands for is closed loop. The other option is open loop. When it's in a open loop, it's not a good thing, because that puts the computer into a default situation, and it runs the fuel-air mixture very rich, just to make sure that it's covering its bases. I've noticed that if I start up my vehicle in this lean position here, well, let me just show you. I'm going to turn off the vehicle, and when I turned off the motor, you noticed it went to an open loop. Now when I start it up, it's staying in that open loop position, and it's running more fuel. It's running at a richer mixture because of that, and it could stay in that open loop for a long time because of this setting on this device where it's set quite lean. So my recommendation, or at least my observation for this vehicle, is I'm going to turn it off again. It's off now. And now I'm going to turn off the adjuster here. And now I'm starting the engine back up. It's running. And notice how it switched to closed loop very quickly. This is a good thing. You want this to be in the closed loop in order to have the additional fuel economy that you're after. So I'm going to start it in the closed loop with this turned off. I'm going to start it with this turned off so that it will go closed right away, and then I'll turn this up to whatever position I want to run at any particular time. Now, I just want to show you the tests that I've done. I'm going to reproduce them now here, actually redo the test, so that you can see the results on the scan gauge yourself. I'm going to switch to the trip gauge. This is at current. I've been driving through town here. My current miles to the gallon is rather low. But I'm going to turn this off, and then I'm going to go out on the highway here in front of us and get it up to speed. I'm going to set my cruise control at 55 miles per hour. It's actually a 60 mile per hour highway, but I'm going to set it at 55. That way it's not too likely I'm going to have to come up behind somebody and slow down, because I want to keep the cruise control on 55 for the entire test, which is 5 or 6 miles down the road here. And with this turned off, I'm also going to turn off my hydrogen. I do have a hydrogen generator on this vehicle. I'm turning it off now so that we can get a baseline setting for what kind of mileage this thing gets by default. So I'm just heading out on the highway now, getting up to speed. Get up to 55 miles an hour here, and then set my cruise control. Right there is 55 miles per hour. I have a marker coming up here that I always start this at, and I will push the reset button right